Okay, manufacturer produces two kinds of table tennis sets. Set A contains 2 bats and 3 bowls. Set B contains 2 bats, 5 bowls and a net. So in 1 hour the factory can produce at most 56 bats, 108 bowls and 18 nets. So let's begin by making our constraints. Okay, so we have set A, let's call that X, 2 bats, 3 bowls. Set B, let's call that Y, 2 bats, 5 bowls and 1 net. We have a total of 56 bats and a total of 108 bowls and a total of 18 nets. So our constraints are 2x plus 2y is less than or equal to 56, 3x plus 5y is less than or equal to 108, y is less than or equal to 18, and of course x is greater than 0, y is greater than 0. So we graph our feasible region. Should look like what I've got here. Okay, we have points A, B, C, D and E. We find the vertices of these coordinates. Okay, so point A has coordinates 0, 18. Point B has coordinates 6, 18. Point C has coordinates 16 and 12. Point D has coordinates 28 and 0, and of course point E is 0, 0. And then we investigate using the objective function what's going to give us our optimal solution. Okay, the objective function always involves some profit or costs. Okay, so we're always trying to maximize profit because money is good, or minimize cost because spending is bad. So we have set A earns a profit of $3 and set B earns a profit of $5. So our objective function is 3x plus 5y. And then we investigate what's going to give us the most profit. Okay, and there's two solutions. We have when we make 6 lots of set A and 18 lots of set B, that gives us $108. But also when we make 16 sets of A and 12 sets of B, this also gives us $108. Okay, now what this tells us is there could be other solutions, because on the vertexes we have 2 optimal solutions. There's potentially 2 solutions and they lie on the line connecting B and C. The other solutions do. Okay, they lie somewhere on this line. So what we need to do to determine those is either determine the line that BC is on. Okay, now if there is going to be more multiple solutions, okay, this line here will have the same form or be parallel to one of the constraints. Okay, we can see here we've got 3x plus 5y. We can see over here we've got 3x plus 5y. That tells us on that line there could potentially be other solutions. We need to investigate this further. How do we investigate? Okay, so we can look at the 3x plus 5y equals 108 and do it manually, or we can use our calculator, and our calculator is our best buddy. So here I've got the region. Now we're going to G-solve. Okay, now at point B we have a x value of 6. Okay, that's there. And at point C we have an x value of 16. So there are 10 points that we need to examine to see if it's potentially another solution. So we're G-solving. Okay, and we're doing a y calc. All right, we've already done when x is 6, so we're going to say, what about when x is 7? Now make sure we select this line. Okay, so I just need to press down there and say, yep, I want this line. Now when x is 7. Okay, y is 17.4, not a whole number. We can't sell 17.4 sets of set B, so that result is negligible. Let's try again. Okay, we're y calculating again, same line again. Okay, let's do when y is 8. Okay, still a decimal number. All right, and we keep going, and I'm aware that there's only one other solution here, but you will need to repeat that a number of times in order to find what the other optimal solution is. Okay, so our other optimal solution occurs, now it's of this line, occurs when x is 11. Okay, so let's call that point O for other optimal solution. So when x is 11, y is 15, and what do you know? 11 is smack bang in the middle of 6 and 16. That's interesting. Okay, so this is point, when x is 11, let's call it point O. So we have 3 optimal solutions. Okay, these are B, O, and C. These have coordinates. B has 6, 18. C has 11 and what was the y coordinate of C? 11 and 15. Sorry, that's point O. And C has coordinates 16 and 12. Now it says in part A, which component is underutilized in each case? So we need to inspect each case, okay? We need to inspect the case for B and see if we're not using all of the bats, not using all of the bowls, not using all of the nets. So let's do that. So let's set up 3 columns: bats, bowls, and nets. Now in case B, we've got 6, we're making 6 sets of A, okay? A has 2 bats, all right? So in total we have 12 bats for set A. In set B, they also have 2 bats, but we've got 18, okay? 18 sets of B. So we have how many bats in total? Let's go into our main calculator to work this out. So what we have is 6 lots of set A, and set A has 2 bats, plus 18 lots of set B, and set B also has 2 bats, okay? We have used 48 bats making set B, alright? We have a total of 56 bats, alright? So we can see there is already some wastage. We're not using all the bats that we can potentially make in an hour. What about if we look at how many bowls we're making? Alright, so we're making 6 sets of A, so that's 6 times 3, and for Y we're making 18 sets, and each Y has 5 bowls, so we have 18 times 5. We're making a total of 108 bowls, okay? So we can see here we're using all of the bowls, so that's got a tick. Here we've got a cross. Alright, we can inspect the nets. We can see we've made 18 sets of B. Each B has 1 net, so we've used 18 nets. Alright, so in case B, there is 8 bats that we haven't used. The factory's made them, but we haven't put them in a set. Alright, let's examine the next case, case O. Alright, this time we've made 11 sets of A, 15 sets of B. So if we've made 11 sets of A, we've got 11 times 2 plus, and 15 sets of B, 15 times 2. This is equal to 52. So in case O, we've used 52 bats, but we still have 4 left over. We're not using all of the bats. Okay? What about the bowls? Are we using all of the bowls? 11 times 3 plus 15 times 5. 108 bowls. Okay, so even in the second circumstance, we've used 108 bowls. Alright, so we get a tick. And we've only used 15 nets. Alright, we could potentially use 18 nets. Alright. So it's about examining each case and seeing in which case the components are underutilized, and then we can make a decision about which case we would like to go ahead with, okay? So just because these are our constraints doesn't mean we're going to use up to 56 bowls each time. It just means we have the capacity to use that many, but we don't necessarily use that many bats or that many bowls each time. So we can see here we haven't used all of the bats. Alright, yep, we've used all the bowls. Here we've used all the nets. Here we haven't used all the nets, okay? So these are faults in our system that it's picking up. Alright, so if I won't go ahead and do part B, but I'll talk about it. Now it says manufacturer discovers that 6 bowls produced each hour are unsuitable. So now we have 102, which means we're changing this constraint from 108 to 102. How's that going to change the system? Alright, we're now determining the optimal solutions. And the manufacturer decides it's more important that we're using all of the bats, okay? So if we investigate the case in part C, perhaps they'll use all of the bats and there'll be an excess of bowls and nets. We say that's okay that we've got excess bowls and nets as long as we're getting rid of the bats. Alright, so in the case that we go with optimal using all the bats, what component is underutilized? So it requires us to investigate it further. Okay, hopefully this makes a bit of sense.